This video introduces you to animating moving objects in Plant Simulation 3D. For this, we use a simulation model with several stations and a conveyor, as you see here. We want to see how moving objects are animated on a station. To do so, we open the context menu of a station and select Edit 3D Properties. Select the tab MU Animation in the dialog which opens. Plant Simulation always creates an animation point called Default for objects of type station. This animation point is used to show the moving object when it is located on the station. To visualize this animation point, we click Show. The animation point is shown with a red path marker on the station. The default setting is to position the moving object with the center of the bottom on this animation point. We want to change the position and rotation of this animation point. For this operation, it makes sense to switch off Snap to Grid and Snap to Object on the Edit ribbon tab. We drag the animation point to the new position and drop it there. To rotate the selected animation point, hold down the Control key and press the left or right arrow key on the keyboard. This will rotate the animation point by 1 degree. If you also hold down the Shift key, the object will be rotated by 45 degrees. If you know the exact position, you can open the 3D Properties dialog of the animation point. To do so, open the context menu of the animation point and select Edit 3D Properties. Here we can define the position and rotation of the animation point. Keep in mind that the position is relative to the position of the station. We close the dialog and start the simulation. Now the parts will be shown at the new position. In the following section, we want to show how to animate objects using an animation area. Place oriented objects like parallel station, store, container, and transporters can have an animation area. In this example, we use the container to demonstrate the usage of an animation area. We first duplicate the container in the folder MUs of the class library by selecting Duplicate in the context menu of the container. This creates a new class object named Container1. We open the dialog of Container1 and set the X dimension to 4 and the Y dimension to 3. Then we open the 3D window of Container1. Now we click Exchange Graphics on the Edit ribbon tab. In the dialog which opens, we select the folder Containers and then select one of the boxes. Plant Simulation asks if we want to set the size of the container to the size of the graphic. Click Yes to use the size of the imported box. If you do not accept the adoption of the dimensions, the box will be scaled to the current size of the container, since Scale Automatically is turned on by default. The graphic of the container now changes to the box. The S3D file we just loaded not only contains the graphic of the box, but also includes information about the animation. This is the difference to JT files, which only contains graphics without any animation. We also duplicate the part in the class library and open Part 1 in a 3D window. delete the graphic of Part 1. This time, we create a graphic of our own. We select Cylinder in the Insert Shape group box on the Edit ribbon tab. We enter 0.05 meters as the radius and 0.3 meters as the height of the MU. We click Create and position the graphic in the center of the frame. To make sure that the object is in the center, we open the 3D Properties dialog and edit the position. Now we can close the 3D window. We need to set the length and the width of Part 1 to the size of the new graphic. Double-click Part 1 in the class library to open its dialog. Select the menu Tools and select Calculate Dimension from 3D. This sets the length and the width of Part 1 to 0.1 meter and the height to 0.3 meter. We then close all open windows except the window of our simulation model. Now we drag Container 1 to Station 1 and drop it there. Next, we drag Part 1 to the box we just inserted and drop it there. We repeat this until the box is full. All instances of Part 1 are perfectly aligned in the box. This is achieved by the animation area of the box. We open the 3D Properties dialog of the box and change to the tab MU Animation. We see that animation area is activated. The orientation defines in which orientation the parts will be shown. The setting XY plane distributes the parts in the XY direction, as we see in the box. The setting XZ plane, for example, can be used if the parts are stacked in a shelf or something similar. Click Show to visualize the animation plane and the MU orientation indicator. The text box Length defines the length of the animation area, in our case of the box. Here we only use 94% of the length of the box, which corresponds to 0.752 meters. Accordingly, we use 92% of the width of the box, which corresponds to 0.552 meters. Within this area, the animation points are equally distributed, as we can see in the box. The length or width of the animation area can be greater than 100%. This is why you can see two dots behind the one. For a container, this normally does not make sense. In the center group, we can specify the position of the center of the animation area. Because the bottom of our box has a defined thickness, a Z position of the animation area is located at 0.016 meters. Next, we want to take a closer look at the animation of length-oriented objects. We open the 3D Properties dialog of the conveyor and change to the tab MU Animation. We do not see any animation path because the animation on those objects is created automatically from the geometry of these objects. On the right side of the dialog, we see MU Side to Attach. Normally, the moving objects are placed flat on the conveyor. Therefore, the center of the bottom side of the moving objects is attached to the animation of the conveyor. Now we want to change the MU Side to Attach. To do so, we select Right Bottom and click Apply to make the changes valid. To make the simulation run a little bit faster, we set the processing time of Station and Station 1 to 10 seconds. We reset and start the simulation. Now the parts will be shown on the conveyor, and the right side of the parts is aligned with the center line of the conveyor. Next, we create an entrance control which varies the width of the products in the source. To do so, we open the dialog of Source. On the tab Controls, we click the three dots of the field Entrance Control and select Create Control. In the method which opens, we use a uniform distribution for defining the width of the parts. We reset and start the simulation. Now we see that the right side of all parts is located at the center of the conveyor, which also is the animation path of the conveyor. You can also define the animation of the products with an arbitrary offset to the animation line of the conveyor. To do so, we just have to enter the respective settings below Animation Offset. The animation offset in the X direction usually doesn't make any sense, and for the Y direction, it only makes sense if you have one straight segment. This concludes our lesson about animating parts in 3D.